Yeah, welcome to our workshop, the NAO workshop, yes, the NAO robots. I will explain in the next 60 minutes how you can program these robots. The NAO, that's the most sophisticated robot for education, humanoid robot for education. Yeah, it started in the year 2005. A French company constructed and developed them. That's Aldebaran Robotics. Yeah, as you can see, they have a lot of hardware. So let's start with the hardware. So we have two video cameras. One is here, one is here. We have 5 microphones. 1, 2, 3, and 4. Yes, we have a lot of touch sensors. 3 on his head. Then on each hand you can find 3 touch sensors. Yes, and here the bumpers. It also has a lot of gyro sensor or acceleration sensors, so he knows always the position of his legs, of his arms, yeah, of his head. So I will show you in the program, in the robot view, yeah, the position of his arms. Yeah, the computer's in the head. The battery is here. And yeah, there are a lot of motors, engines. How much do you think? How much motors do we need?
10?
Oh, more.
More. 100.
Ah, too much.
Yeah, well, the fingers are different, right? Every finger has it.
Yes, he has 25. So I will show you also in the software, yeah, where the motors are located. I think that's the best way. Yeah, so let's start.
When you said that the cameras, are those 2 eyes the cameras?
No, the cameras are not in the eyes, so that's too complicated. They are located here and in the mouth. Okay. Yeah. Here there are some infrared sender and receiver. So yes, here you can see also ultrasonic sensors. Yes, software, it's powered by Linux. Yeah, now a Linux system starts. And I can also connect to the robots. Yes, via PuTTY and change the start scripts. Yeah. Yeah. Yes, to upload the program, it's the easiest to do it by Wi-Fi. So I have a small router here, access point. Yeah, and this is the NAO network. I've configured it, so you will see it already. It's the NAO network. And the robot connects to this Wi-Fi router, and yeah, they're in the same network and they can communicate together. So that's the big advantage. It's also possible to configure the robots so that they are Wi-Fi router by themselves. Yes, but the disadvantage is each builds its own network. So I use this router here. Yes, some information about me. I'm Bernhard from Vienna, Austria. My main profession is I'm IT trainer, consultant, but not for Python or NAOs, for Java Enterprise. And yeah, I've studied computer science, studied computer science education too. And I founded an organization 4 years ago, and we organize and perform robotics workshops for kids and youth with different technologies. So we use B-pods for children in the age of 4 to 6 years. We use Arduino. Yeah. We are also using Lego Mindstorms EV3, and these two are our superstars. So this is Naomi This is Frank. Yeah. Yeah, we organized last year 110 workshops in Austria, so there are really a lot of workshops. And our idea is, our vision is to motivate children, yeah, to learn programming. And I think robots are the best way to learn it. Okay. Yes, this is the default programming environment. This program is called Choregraphe. It's available in a trial version for 90 days. So I have the Windows version already on the stick, and I'm downloading the Linux and iOS version. Okay. So this is the programming field, and here we create our program. So I just customize the views. We don't need this. So here the boxes. We can close this. Video monitor. Robot applications. Okay, that means one of these robots has been started now. Yes. When you start this program, you can find a robot already, so that's a virtual robot. And you can do most of the programming with this virtual robot. You can test your programs with it. And yeah, after testing, you can test it with a real robot. And that's our idea today, so that you implement some programs, test it with this virtual robot. And then, when you say, okay, it has no bugs, you can test it with the robot. Yeah, I will connect with one of the robots. I have to change the network now. And I'm connected with the NAO network. Okay. And after a while, there should be now Naomi and now Frank available for selection. Yes, and yeah, here you can see if you press the mouse button, yeah, you can change the position of the camera. Scroll in, scroll out. Yeah. And yeah, that's the position of Naomi. So if I move the hand here, the arms.
Oh, really? Oh, good.
The head. Yeah. Yeah, then I show you the monitor. So there is another program included. It's the monitor, and here we can see what the robot sees. Yeah. So this is the monitor application, and yeah, I can select the camera. I can switch the camera, but it takes some time. Okay, Naomi. Oh, mark detection, face detection. Yeah, so this is that's the video now, video stream from Naomi. And yeah, you can see that also the faces are marked. Yeah, with the cross, with the blue cross. So we can use it later for face detection. Yeah, he can learn, the robot can learn faces, and you can store some names or IDs to a face and use it in your programs. Yeah, the second camera, it's the camera and the mouse here. Yeah, this is the table. Okay. Yes, another thing, here you can see the motors that are built in. And there are a lot, so that's the right arm. And yeah, I have to stiffen the chain, yeah, stiffen the engines. And now I can move its arms. But yeah, it's much simpler to program it. So we have a lot of boxes here, and we just have to use the boxes here. So we can say, okay, stand up, say hello, yeah, say something to us, and then sit down. So here you can find some boxes for motions. So what do you think? Which box do we need? Yeah, stand up. So when it stands up, yeah, it doesn't matter if the robot is lying on his back or on his belly, or if he's standing already, it goes to a standing position. Yeah. And so there is much intelligence inside of these boxes. Yeah. Yeah, then there is an animation for hello. And then we say, okay, sit down. Yeah.
Is it possible to like see what this would look like in Python? This
Yeah.
program?
Yeah.
Can you simulate that program? Can you make 3D avatar do? What does it do?
So we don't need this robot view now. Here. This is behind the boxes. Yeah, this is the Python code. So I can change this.
Wait, is that the whole program or just one box?
No, this is just for one of these boxes. Yeah, I will explain it later. Yeah, so we will start with the graphical interface and then we will switch to the Python API. The truth is, behind each box there is Python code. Yeah, and there is a robot framework. It's called Naoki, and it has different modules, and each module has different lot of functions. And here only the functions of the API are called. And yeah, you can see there the module. The module is R robot posture, and then we call the function go to posture, and we have to hand over a constant. Yeah, I think here we say stand. And yeah, and then he stands up. Yeah, you have seen already I've connected the boxes with the start point, and I connect the last box with the final output. Yeah, and now I will upload the program to the robot and start it.
Is it possible to simulate that program as well?
He has to keep it, right? Can you one last time, please?
You will see much better things later, so
Okay. You promised. Just the beginning.
yes. It's also possible that the robot says something. Yeah, that's very easy. You have a say box here, and yeah,
Something stupid.
with a double click you can say okay, English, German, a lot of other languages, but yes, these two robots can only speak English and German.
Okay.
And then you insert the text. Yeah, you say, hallo, mein Name ist Naomi. Yeah, and it's also possible that you do things concurrently. Yeah, I can connect this box also with this output.
Is it like that you have to connect it exactly with those, with those boxes? So exactly when he's, for example, when you connect it to the like staying position,
Yeah.
you're exactly going to say this in the moment of staying position. Is it possible like to connect it with the, for example, like in the middle when he was standing up, for example, and saying something? No.
No.
Then you have to create your own.
Yeah,
Okay.
yeah, you have to create your own boxes, or you use the wait box.
Okay.
Maybe you can synchronize it a little bit. Yeah. Yes, what happens
I
here?
have a question.
Yeah.
What is the difference between animation? Animation is just one of the boxes, right?
Here motions. No, it's just a subdirectory. So
Hallo, mein Name ist Naomi.
Hi. She's so hard.
So, but yeah, I will change the stand up and sit down box by wake up and rest. So he's much faster than rest is sitting position, stand up. Yeah, a question to you, when is this rest box executed called?
Is this the rest position?
No, he's now in the sitting position. So the rest position, yeah, I can execute the program and then,
Hallo, mein Name ist Naomi.
oops.
The rest is the
Yeah, we need a stand up, then we can say rest. Okay.
Hallo, mein Name ist Naomi.
So this is the rest position, yeah, and it stands up much faster from this position. Yeah, but when is this box executed? When?
after hello.
Yes, after hello. But maybe not after the say box. Yeah. So we can change it. We want that the rest box is executed after the say box. But there are also control structures, flow control structures included. And here there is something like wait for signals. And that you can use when you want that the rest box is executed after the hello box, or after finishing the hello box and after finishing the say box. Yeah, that's the idea of this wait for signals. And I don't know if you know the Petri net. So this is, I think this is a Petri net implementation.
What is speaking? I don't know.
Yeah, it's similar to activity diagrams, and you can see the tokens here, and the tokens stimulate the input of a box. Yeah, and when the input is stimulated, then the functionality is activated, and after that it sends the token to the other boxes. Yes. You can see the token here. Yeah, it's the connection is always green. Yeah.
Hallo, mein Name ist Naomi.
Here. And here. Yeah. Yeah, there are also some control structures. If only one, there is a counter you can loop for a for loop. Yeah, we can implement an example together then. Only one means that, the box is stimulated, then it sends the signal to the next box, but it do this only once. So if you stimulate it a second time, then no signal is sent to the next box. Okay. Yeah, with motions you have also simple dances like Tai Chi. So, yeah, I will show you the Tai Chi. I like to dance. Yes, but we have to change the language, yes. I have to say, okay, set the language to English. Okay.
I like to dance.
Yes, and you have seen already that we can change some of the parameters of a box. Yeah, we can change it by clicking on the screwdriver here, and here for stand up it's defined maximum of tries. Yeah, so we can say okay, maximum of tries 3. Yes, and when he's not successful in standing up, then he would fire the signal by this output. So you can see there are 2 inputs, yeah. One the normal input, and there are 2 outputs. One is the success, and one is in case of a failure. Then he sends the signal by this to this output. Yes, and yeah, that's the idea behind programming via Choregraphe. Yeah. It sends the signal to next box, it's activated, started. Yeah. Yes, and here you can find a lot of boxes. Here one of these boxes move to. We can also try it. We say stand up and then the now will walk. So you have 3 parameters here. One is x, y, and theta. So x is this direction, y is this direction, and theta is he can turn during walking. So if you say 0 for x, 0 for y, and 90 for theta, then he will take this position. So let's start with he should walk a half meter. Yeah, it's also possible. So when I start a program here, so I can activate boxes by double clicking on the input. Yeah. So we can say, okay, stand up and start walking. Okay, after that I can say, okay, go to the rest position. Yeah, let me show you with 0, 0, 90. Then yeah, but there is a bug in the software, so sometimes it fires the signal over this output. So you must always connect both of these outputs to the next input. Yeah. Yeah, there are also some. There is a box for open the hand, for close the hand, or yeah, stand up. Choice flow control. Yeah. Have you finished the download already? Okay. Yeah, then I will continue. So let's program together a short program. So the NAO should count from 10 to 0. How can we do this? So you should say 10, 9, 8. Yeah, we need a counter. Great idea. So yeah, it's not necessary that he stands up and rest. So we need a counter. Here we can configure some values: initial value, step value, final value. What do you think? What's the meaning of these parameters? Initial value.
Initial value is the start value, step
So
change.
value for it is 10. 10. The step value,
-1.
yeah, but it's okay for the now to say it's 1. We don't have to say -1. Yeah. And the final value is, so we take 1, not 0, yeah, 1. And the idea is, I can show you the behavior of this box. When I stimulate this input here, it sends the first value here, 10. So you can see it's not only possible that he sends a token, yeah, a signal to another box, it's also possible that he sends numbers and strings, also some other data to the next box. Yeah. When I stimulate the input here next time, second time, 9, 8, 7, 6.
So we should keep it in a loop?
That's the loop.
No. Then,
Okay, yeah, I understand. Yeah. Yeah, that's the year 3, 2, 1, and now. Have you seen it? So after the last value, yeah, he stimulates this output. And that's the construct we can use for a loop. Yeah, we can say, okay, we don't use the say box. You can find by advanced say text. Yes, it says the text which is sent to this input here. Yeah.
Ten, 9, 8, 7, 6.
Yeah. Next step. We use this box. This has the same meaning, yeah. Same outcome. Okay. Kannst du ihn noch einmal berühren? So you can see it's still firing the signal to the next box, but the only one box filters the signal. So that's the difference here. Yeah. It's a blue stick. Yes, that's the way how we can use the sensor. So another example, yeah, we can use also the foot contact. So, but he must stand up before. So motions. Stand up. Yes, and it fires a signal if both feet are in the air. Yeah, and here it fires a signal when at least one foot is in contact with the ground. So
you can jump and run?
Do cartwheels?
I always show children, I don't know, Diebstahl.
What is Diebstahl? Theft?
Theft?
Yeah, so no. Don't steal me, is that correct?
Ah, you can pick them up, basically.
Don't pick me up. Okay, thank you. Ja, du kannst jetzt hochheben. Nee, den Roboter kannst du jetzt hochheben.
No, don't pick me up. No, don't pick me up. Okay, thank you. No,
Yeah.
don't pick me up.
Ah, so it doesn't fire if one signal is still being processed,
Yeah.
like the up signal,
Yes.
it doesn't fire the down signal,
Yeah.
or wait for it.
Yeah. Oh, yes, the possibilities. You can ask if the robot has special hardware, yeah. Because you can also buy this robot just with the head and the thing. Or you can just buy the foot, yeah, parts of it and program it. And
What does the robot cost?
5,500 euros. But I paid a little bit more.
Price is going down.
Yeah, it cost 12,000 2 years ago. So
What's the difference between we have an expert version and there is this normal version? I think the entry version costs around 5,000 bucks and the expert version costs around 9,000 bucks.
no, it's the same price.
Okay, in the internet I had some research and there was some guy who said, okay, this is an expert and it costs 9,000 euros.
No, that's too expensive. No.
Okay.
Yeah, you can also ask the temperature of the motors. Yeah, so you can say, okay, say me the temperature of the L shoulder roll. So that's one of the shoulder motors, yeah, left. And we send it to the safe box. So he is standing already, so
40.
yeah, that's the temperature of the L shoulder roll motor. And yeah, it's also possible to change the behavior of the fall manager. So it has a fall manager included. Yes, a fall manager. He's protect his head when he's recognizing that he's falling. So I can show you. Are you ready?
Oh, you don't have to program it.
No, no. It's always activated. I can deactivate it. Yeah.
Ouch.
Yes.
Once more?
Ouch.
This guy's an intelligent girl.
Yeah, this is the way how you use the different sensors of this robot. So last thing I want to show you is the speech recognition. So you have to define a word list here. Yeah, you can say, okay, we want to distinguish between yes or no, and the confidential threshold is 30%. So let's activate this box. Yes. No. Yes. Yes. So he sends he sends the word that he thinks he understood. Yeah. Here this output, and we can use it. And the normal way is that we say, okay, when it's recognized one of these words in our list, we want to deactivate the speech recognition, and we use the switch case construct. And here you must use the same. It's case sensitive, the same words in the switch case. So here we can say yes, and here no. Yes, and you can see now we split up the outputs, and here we can do some actions. Yeah, we can say, we say yes, then we will dance. When we say no, should sit down. So that's the difference is the typical switch case component here. So you can have more than one value.
I think switch is like case,
Yeah.
switch, and then
Yeah.
I don't know if Python has that.
A Python,
C++
okay.
Has, I don't know about Python at all, but C++ has it, or C.
Okay, now it's deactivated. Yeah. So, okay. So let's do something which is more useful. We say stand up, sit down, and dance. Here, stand up, sit down, and dance. Yeah, then we need some boxes here for the stand-up process, for the sit-down. Yes, and then I will use one of my better dances, so Gangnam Style.
Did you create that?
No, just copy it.
Okay. Is there somewhere a detailed way to create our own box? Customized box.
Custom symbol, which you can put your own code there.
How do we create that?
Now, there is an app store and you can download some, but
Yeah, how to create this app?
no, you can see different versions. But it's much easier to create some dances. I can show you later on. So you have a timeline and you just have to define the endpoints of. No, I can change it. I can change the Python code of each box.
Okay.
Yeah. So yeah.
Well, that means that the code is insecure, right? Because if someone else creates...
No, the code is not secure. No, you can change it. Okay. Stand up. Dance.
Opern Gangnam Style. Gangnam Style. Opern Gangnam Style. Gangnam Style. Opern Gangnam Style.
Come on, the best part comes now.
Sit down. But now, dance.
Opern Gangnam Style.